Welcome back to the series, guys, where we are discussing the solutions of activity questions. So, in the previous video, we have discussed the questions till question number 7, and in this video, we are going to discuss question 8, 9, and 10. So, let's get started. Here in the question 8, we again have to choose the correct set of options. So, let's get started. In the first option, it is said to us that there exists some real matrices A and B such that AB is equal to BA. So we know that in general, AB is equal to BA. In general, in general, AB is equal to BA is a wrong statement, right? AB is not equal to BA. But the question is asking that there exists some. That means even if we are able to provide few of the example, then the option would be correct. So if we take some example like, but let's say B is equal to I. What would happen in that case? So we have seen A times I is equal to I times A is equal to A. Correct? So we have shown that in this case, AB is equal to BA. Similarly, if you take A equal to I, similarly, if you take A equal to I, what would happen in that case? You can write I times B is equal to B times I is equal to B. So we have shown some of the examples where AB is equal to BA. Even if you do not take A as equal to I or B as equal to I, or if you take some other value of A and B, in that case as well, you will get AB is equal to BA in some of the cases, in some of the examples, right? So it is not a hardline rule that every time AB is not equal to BA. Yes, in general, it's not true, but it's not correct to say that it cannot be correct. It cannot happen anytime. So option number 2 is incorrect, that they do not exist. So because they do not exist corresponds to there is no such example. And we have just seen that no, there are some examples. Now moving on to the option 3, that there exists some matrices such that A square is equal to Y. So again, if we take the example of A equal to I. So in that case, we know I square is equal to I again, right? So we have given some example of A square is equal to I. So we can say that there exists some real matrix such that A square is equal to I. So option 3 becomes incorrect again, because option 3 says there does not exist, right? So if we write one more point here, that these type of matrices have a special name called idempotent matrices. Idempotent matrices. So any matrix A such that A square is equal to A again, I matrices such that A square is equal to I. So such matrices are called idempotent matrices. And now coming on to the fourth option, where it is given to us that there exists some real matrix, okay, where it is given to us that there exists some real 2 cross 2 matrix A such that A square plus A plus I equal to 0. A square plus A plus I equal to 0. So we again have to show that there exists some matrix. So let's say if we take the example of A equal to -1 1 -1 0. So what would be the value of A square? The value of A square is going to be -1 1 -1 0 times -1 1 -1 0. And if we take the product, it's going to be -1 times -1, 1 times -1, it's going to be 0, minus 1 times minus 1 is 1. 1 times minus 1 is minus 1. So it's going to be 0. Then we have minus 1 times 1 and 1 times 0. So it's going to be minus 1. Similarly, we have minus 1 times minus 1 plus 0 times minus 1. So it's going to be 1. And then we have minus 1 times 1 and 0 times 0. So it's going to be minus 1 again. So now if we do a square plus a plus I, here if we do a square plus a plus I, so it would be 0 minus 1, 1 minus 1 plus, what's the value of a? It's minus 1 minus 1, 1 0, and the value of I is 1 0 0 1. So now if we add all the terms, what do we get? 0 plus minus 1 plus 1 is 0, minus 1 plus 1 is 0, 1 minus 1 is 0, and minus 1 here and 1 here is 0 again. So that is equal to 0. So that means we have shown an example where a square plus a plus I is equal to 0. So that means there exists some real 2 cross 2 matrix A such that a square plus a plus I is equal to 0. So that was all about question 8. Moving on to the question 9, there is some glitch, that's why you are seeing those lines here. Moving on to question 9, we have A is a 3 cross 3 scalar matrix where the 1 entry of the matrix is 4. So we are given that 1 1 is equal to, suppose, and A is a scalar matrix. So since A is a scalar matrix of order 3 cross 3, A could be written as K times some identity matrix of order 3 cross 3. So because we know the value of A11 is 4, that means the value of K is 4 as well. Why? Why so? Because let's say the value of KI33 would be K, 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 0, 0, 0, 0, 0, 0. And we are given that this entry, that is A11, is equal to 4. That means K is equal to 4, right? So A could be written as 4 times I. And why we did that? Since A is a scalar matrix. Okay. Moving on to the next part of the question where it is said that B is a 3 cross 3 square matrix such that the ijth entry is equal to I square plus j square. Let me change the correct color. Here it is given to us that B is a 3 cross 3 square matrix such that ijth entry is equal to I square plus j square. So in B we can say Bij is equal to I square plus j square for all the values of Ij being 1, 2, 3. So I is 1, 2, 3 and j is again 1, 2, 3. And we'll do for all the combinations of I and j. Find the 2-2th entry of the matrix 2a plus b. See, so we know one thing, that if C is equal to a plus b, then Cij is equal to aij plus bij. So here if we want C22, so it's going to be A22 plus B22, right? And here I am defining my CS. So if I define my CS 2a plus 2 or 2a plus b. So in that case, my C my Cij would be defined as C22 is equal to 2A22 plus B22, right? This was rather a general statement. So let me put that statement inside a box. Now, coming back to the question where we have to find C2. So C22 is equal to 2 times A22. So value of A22 is 4. Here we have seen that the value of A22 was K and the value of K is 4. Now, talking about B22. So B22, again, there's same glitch. Yeah. So B22 is nothing but 2 square plus 2 square. Why? Because Bij was I square plus J square. So here we can see there is some 8 plus 4 plus 4. There is 8 again. So C22 is going to be 16. And that is the answer for the question. Now moving on to the question number 10, where we have a matrix given to us and there is some expression that a square minus alpha a plus I is equal to 0. Then find the value of alpha. So let's solve this question. So first we have some a. So let's try to find the value of a square. The value of a square could be found as minus 1, 2, minus 4, 7 times minus 1, 2, minus 4, 7. So what would be the value? So it's just minus 1 times minus 1 is 1 and 2 times minus 4 is 8, minus 8. So 1 minus 8 is going to be minus 7. Then moving on to the second value, it's minus 1 times 2 minus 2 plus 14, it's 12. 4 minus 28 is going to be minus 24 and minus 8 plus 49 is going to be 41. Say it plus 49 is going to be plus 41. So now again putting values of the expression a square minus alpha times a plus I is equal to 0. So if we put the values in the equation, that is minus 7, 12, minus 24, 41, minus of alpha times a. So a is minus 1, 2, minus 4, and 7 is equal to minus I. Right? So if we take I to the right hand side, it would be minus I. Now again, writing this in a single line would be minus 7 plus alpha. Then we have 12 minus 2 alpha. Then we have minus 24 plus 4 alpha. And then we have 41 minus 7 alpha. And it is equal to minus 1, 0, 0, minus 1. Now again we know if two matrices are equal, then it means their corresponding terms are equal. Now here we can compare any of the corresponding term. So let's say we are comparing 12 minus 2 alpha with 0. So 12 minus 2 alpha is equal to 0. That means 2 alpha is equal to 12 and alpha is equal to 6. So here the value of alpha is coming out to be 6 and that is our answer in this case. So here we discussed question number 8, question number 9 and question number 10. So now at this point you might be having some questions and those questions would be regarding this option B. Here we took the example of A where A was equal to minus 1, 1, minus 1, 0, which satisfied this equation. So you might ask that how you got this matrix or is there any way to get these kind of matrices? Yes, there it is. So let's discuss those methods. So let's add a new slide here. So if we have an equation and if we want to find the value of A that satisfies that equation, so usually what we do is we start with an arbitrary matrix. Here we are starting with A, B, C, D. So we want A to satisfy A square plus A plus I equal to 0. That means first we'll have to calculate the value of A square. So to calculate the value of A square, we'll just multiply A with itself. So A, B, C, D will get multiplied with A, B, C, D. That will give us a new matrix, that is A square plus BC, and here it is going to be AB plus BD, and then we will be having AC plus DC, and then it would be BC plus DC. Okay, now let's put the value of A square and I in this equation. So A square plus A plus I equal to 0. Here if we take A square, it is going to be A square plus BC, then AB plus BD. Here we have AC plus DC, and then we have BC plus D square. This was our A square. Now, let's take the value of A, which is A, B, C, D, and then we have an identity matrix of order 2, that is 1, 0, 0, 1, which is equal to 0 matrix, 0, 0, 0, 0. So if we do this, we are getting A square plus BC plus A plus 1. Then we have AB plus BD plus B. Then we have AC plus DC plus D. And then we have BC plus D square plus D plus 1, and all of it equal to 0. So if we compare the corresponding elements on both the sides, we can obtain 4 equations here. And what are those 4 equations? First, we have A square plus BC plus A equal to minus 1. Then we have AB plus BD plus A plus B, maybe let's check. Yeah, plus B equal to 0. Then we have AC plus DC plus C. So AC plus DC plus C equal to 0. And then we have BC plus D square plus D. BC plus D square plus D equal to minus 1 as our equation 4. So now we will have to choose the value of A, B, C, D such that all 4 equations are satisfied. So I'm starting with D equal to 0. So because I know if I take D equal to 0, the equations will get more simplified. So if I take D equal to 0, I'll be left with this equation A square plus BC plus A equal to minus 1. Then I have AB plus B equal to 0. Then here I have AC plus C equal to 0. And then I have BC equal to minus 1. So these are my new 4 equations. So if I check equation 1 and equation 4, that is these 2 equations. So here I can substitute the value of BC equal to minus 1. That would give me A square plus minus 1 plus A equal to minus 1. And minus 1 will get cancelled out and I'll be left with A square plus A equal to 0. So here I have 2 possibilities for A. Either A is equal to 0, or if A is not equal to 0, maybe I can take A common from both the side. I can take A common, and if A not equal to 0, I can uh, divide both sides with A, and then I'll be left with A plus 1 equal to 0, and here I will get A equal to minus 1. Now let's check whether we can take A equal to 0 or not. So what will happen if we take A equal to 0? So if I take A equal to 0, uh, and let's name these equations. So this is my equation 1, this is my equation 2, this is my equation 3, and this one is my equation 4. So if I take A equal to 0, I will get B equal to 0 and C equal to 0 from equation 3 and equation 2. And if B and C both are 0, then their product will also be 0. That means equation 4 will not get satisfied. So this will not satisfy equation 4. So that means A equal to 0 cannot be the possibility. So we will continue with A equal to minus 1. Let's see what will happen if we continue with A equal to minus 1. So as of now, we know that B equal to 0 and A equal to minus 1. Okay, let's see what will happen. Now we are left with these equations. So BC is equal to minus 1, AB plus B equal to 0, AC plus C equal to 0. Given that A is equal to minus 1, so that will satisfy our equation 2 again, because minus B plus B is equal to 0 for all the values of B. Minus C plus C is equal to 0 for all the values of C. So we are just left with BC equal to 1. Minus 1, sorry. So if BC is equal to minus 1, we can take any combination of B and C which will result in minus 1. So let's say I can take B equal to 1 and C equal to minus 1 maybe, or I can also take B equal to minus 1 and C equal to 1. I have other options like taking B equal to minus 1 by 3 maybe, and then C equal to 3, and so on. So there are endless possibilities of choosing B and C. So if I have A, B, C, let's say I'm moving ahead with this particular example of uh, B, C, A and D. So I will get A equal to minus 1, D equal to 0, B equal to 1, and C equal to minus 1. So this is one of the matrix that I have obtained, which will satisfy this equation A square plus A plus I equal to 0. So whenever you are in such situations, you can always take any arbitrary matrix A, B, C, D, and you can test whether it is possible to obtain any combination of A, B, C, D that would satisfy this equation or not. So this was all for this video. We'll see you in the next video. Till then, have a nice day.